Okay, so I am keenly aware that today's warm-up is the same as the question that I asked you to do last night, so there are several purposes for me doing this, and you'll find out over the next few minutes. Let's start with answers, and when I call on you, I would like the values of x, y, and z. So you'll say x equals, y equals, z equals. All right? Student number 2, 18, 17, and 13. Student number 2, what'd you get?
X equals 54, approximately 54.41. Y equals 44, and Z equals 32.
Okay, student number 18.
X is approximately 54.406.
And y and z?
Y is equal to 44 and Z is equal to 32.
So I think that was about the same as the previous person. Student number 17.
X is approximately 54.4, Z is 32, Y is 44.
Okay, student number 13.
X is approximately 54.4 inches, Y equals 44 inches, and Z equals 32 inches.
Okay, so we seem to have some agreement. Y is approximately 54.4. I should have used the approximately equal to symbol, but I did put in the exact answer here. That's what it comes out to exactly. So the bigger issue, and I was glad to hear some people immediately engaging in discussion, was how. So now I want to talk about path of logic, path of how you got to the different values. So I want you to think about what you did. Now I know many of you did it last night, but hopefully as you looked, you thought back to what you did, and as you heard your classmates talking about it, you listened to what they did, and maybe you discovered something you hadn't considered before. All right, so we'll start Sebastian, Dalton, Catalina, Brandon, Ann, Zabari, Michaela, Alicia. Try to remember what the order was. Go.
What I did was I first found X by finding the length of one of the small triangles with the 8 and 11 is
Okay, so Pythagorean theorem right here, got that, and then you did what?
and then I multiplied that by 4 because the four small triangles have perfectly modules of the triangle. And then for Y, I
Well, how do you know you could just multiply it by 4? But how do you know they're the same?
logic.
Logic? Are you sure? Can you just assume that? Alyssa? Oh yeah, it says it right there. It says it right there, of course. Thank you. So you were right. I was just trying to make sure you gathered the evidence before you said something. Okay. And so pause there for a second. Give me a thumbs up, everybody in the room, if you found X using that same method. Okay, put your thumbs down. So it seems pretty universal that we found X that way. Okay, good. So Dalton, were you next? You found X that way, so what about Y?
I multiplied 4 times 11 because I knew that if you multiply the X times 4, that you would get the hypotenuse because you did the primary theorem.
Uh-huh. Are you sure?
No.
Well, let me ask you this. Did you get the right answers?
Yeah.
Okay, so it worked.
Yeah.
Okay. Can someone... So, again, you took the 11 and multiplied it by 4 to get the y. All right? So back to the whole group. Give me a thumbs up if you found y that way. We have a few people. Okay. All right. Put your thumbs down. Daniela, did you get the correct value for y? but you did not do it the way he said. What did you do? Okay. So you use the trig functions to find the missing side. Because now we know this side, and you were able to figure out this angle here. Well, if you look, if that's a right angle, and we're assuming that these are parallel, then that has to be a right angle. So yeah, you could figure out, I think, what that angle would be. So, all right, totally different method. Alyssa, you also did not use Dalton's method. What did you do? Use some trig functions, and did it work out for you? Okay, so to illustrate Dalton's, though, I want to do something. Let's see if this makes it a little more clear for some of you. So watch this. So can we all, I mean, I know I went a little bit over, but can we all agree that that's basically the length of the step? So watch this. What could I do next to prove Dalton's idea? Brandon?
You can do the same thing you did for the line drawing.
Yeah. So watch. If I make another one of these and I bring it here, now move them both down. Move that down to there, move that down to there, and I know it's not perfect, but it actually works out. So I am now halfway across the bottom by going up these two steps. If I do the same process here, you will see that if I drag them down, that these 4 steps is the same distance as the whole bottom. And so Dalton's theory was spot on, that if you take the 11 and multiply it by 4, you get 44 right here. So this is 44 because of the 4 times the 11. Took me a while to see that. I definitely went with trig functions first, and then as I looked at it more, I realized, wow, actually didn't need to do that at all. What about Z? What about the height of the staircase? What'd you do there? I lost my order. I think Catalina was in there somewhere. Go ahead.
Well, I did it still using the trig functions, but now it's also from that one. You could also do 8 times 4.
Yeah, so you can take the same approach for the risers. And these, I think, are technically called the risers when you talk about a staircase. And so if I draw this line here, and if we now drag that line straight across over to here, there will be 4 of them stacked up exactly because we've got 1, 2, 3, 4. And so the same technique works. And it seemed like there was, I don't know, maybe more than half the class had figured out this technique. I feel kind of silly myself. I actually figured it out using the steps, so I figured out why, but for some reason I didn't see it this way, and so I then used the Pythagorean theorem to find Z. Myself, I feel a little silly that I didn't realize that I could have just multiplied it by 4. But what doesn't really matter, we got the same result, okay? And you said originally use trig functions to find? Good. Okay, so there was a bunch of other people. I don't want to deny you your chance to speak. Anne was in there, Zabari, Michaela, Alicia. Anne, what? Oh, and I'll come back to you. Hold on. Anne, go ahead. You saw it. Did you see it immediately, or did you just kind of...
Well, first I found the hypotenuse of the triangle, and it just makes sense.
Okay, good. Zabari? Same thing, okay.
I found Y the way that Dalton did, but I didn't see the Z
Yeah.
like you did, but I did it the way Catalina did, and you used the Pythagorean theorem.
Okay.
I used cosine and
Oh, okay, good. Because you now have 2 different values. You had X and Y, you can find the Z. Very good. Alicia?
I don't know if it's the same thing, but I used proportions.
Used a proportion, okay. So did you set up a proportion with the small triangle and the big triangle? Okay. Interesting. Okay, Brandon? Okay, very good. Any other thoughts on this? Any observations? Any theories? Good, we're doing, yes, Brian, go ahead.
When I was solving it, I found that the small triangles and the large triangle were similar
Okay,
by AA postulated, so I just solved for y and z using that.
okay, and which is what Alicia did. Did you prove that they were similar, or did you assume that they were similar? You assumed, okay. And I think it's, I mean, I probably would have, thinking about it now, I would probably assume it, but you want to make sure that you have the evidence to support it, because that's something that might be visually look correct, but it might not be true, or it could be true. You just want to make sure you have that evidence, okay? Very good. So thank you for sharing. Any other comments, questions? Good. So again, this is lesson 8.1, and we're going to be exploring the properties of polygons. You did an exploration last time we were together where you've already discovered some of it. Our objectives for today are to be able to classify polygons. We actually already did this a long time ago. And to be able to use interior angles and exterior angles to solve some problems. Got quite a bit of new vocabulary, but none of it too complex. We've got side of a polygon, vertex, diagonal is something that we're going to be exploring a lot. Regular polygon, that's something that's come up before. Concave and convex. Any questions right off the bat? Now, you are very mature, very bright young people. You're in geometry honors. I am going to be putting up some notes. You can decide for yourself whether you need to write things down. Do not write everything. That would be ridiculous. Write down ideas that you know that it's going to be difficult to remember, that you're going to need to refer back to, and try to figure out, which ideas are simple ideas that you know by the end of the chapter, they'll just have magically kind of gotten into your brain. Okay? And I'll help you along as well. So, let's start with polygon. So I've got one drawn out here. So here are the different parts. You've got vertices, and you connect them, you form the sides. The endpoints of the segments are called vertex or vertices. And then if you connect two non-consecutive vertices, two vertices that are not next to each other, then that's called the diagonal. So you can't draw a diagonal from B to C. You have to skip over a vertex to draw a diagonal. Any questions about the basics? Good, let's move on. So, now we have two different kinds, concave and convex. And if you know the words concave and convex already, then there's really nothing to worry about, because it's the same idea. To make it a little more formal, we say it in a very mathematical way. If you can connect a diagonal between two vertices and it ends up outside of the polygon, then that is called concave. If you can only draw diagonals inside the polygon, then that's called convex. We are going to be dealing mostly with convex. Here is the diagonal outside of the polygon. Any questions about that? A regular polygon is always convex. So you have to think back, what does regular mean? What does regular mean? Davis, what's a regular polygon?
All the sides and I believe all the angles are, it's all equal angular and equal. The other part is, but it has all equal sides and angles.
Beautiful. You said that. Great. Great words you used. The other one you were looking for was equilateral and equiangular. Absolutely. That's great. That's really important to understand that a regular polygon, equilateral, equiangular. Any questions about that? Good, we're doing well. So now, your cheat sheet. So now we've got some ideas that come out of your exploration yesterday, and some ideas that you didn't get to explore yet, that we're going to explore a little bit in a moment. First of all, the polygon interior angles theorem says that the sum of all of the angles inside a polygon will be n minus 2 times 180, where n is the number of sides. N-gon is the way you say a polygon's name if it's more than like 12 sides and you don't know the name of it, you just say 13-gon because you don't know the name. You should know triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon. Beyond that, I don't remember most of them beyond that. Dodecagon, I think, is a 12, something like that. But beyond that, you could just say 11-gon, 13-gon, 20-gon. It's fine. Okay? Good question. Now, here's a corollary that honestly, you don't even need to remember really as far as the name. But based on this, we know that the interior angles of a quadrilateral will always add up to 360. Beyond that, you don't have to remember what they're going to add up to because you can always calculate it using this. So the corollary is kind of extra. Honestly, if we use it in a proof, I'm okay if you just stated it rather than writing the name of the corollary. I don't think it's that big a deal. Which leads us to the idea you discovered yesterday, which was very interesting. When we added up the exterior angles, no matter what size the shape was, no matter how many sides the shape had, what did it always add up to? 360. So if we have a pentagon and we extend the sides so that we create external angles, 1, 2, 3, 4, 5. 5-sided shape will have 5 exterior angles. 6-sided shape will have 6 exterior angles. But no matter what, they will always add up to 360. And that was the exploration yesterday. And?
Isn't a polygon basically a circle with a
Maybe. Where did you discover that?
Well, it makes sense to me because if the outer angles add up to 360 and the circle is 360.
Right.
So it must be related.
Okay. And I think you're right, that it must be related somehow. Absolutely. So I love the idea and the theory that you came up with. So just to put a picture to what you're saying, you're wondering right now, is this really taking this circle and putting a dent to it, meaning you're like pushing down right here so that we end up with a flat side from there to there? Is that what you were trying to figure out, like that? You're pushing down a little bit, and then we push down a little bit over here. Oh, excuse me. Push down a little bit over here, and then we end up with another side like that. Yeah. Yeah. I like what you're thinking. It's been a long time since I've done calculus, but a large part of calculus is based on the fact that the more sides you add, the closer it gets to a circle. And I'll do something a little bit later on that. Go ahead.
Is there going to be a theorem of exterior angles about
I'm not sure. I don't think so, but I'm not sure. Okay? I'll look it up for you. All right? Other questions? All right, so we explored this yesterday. I want to explore this one, polygon interior angles, a little bit. So we're going to take a moment with this. So here's what your job is. All I did was put up the theorem again, so that's not anything different. But now I've given you 4 pictures. And I'm going to give you 2 minutes 2 minutes, and I would like you to tell me, as a team, where does the 180 come from, and where does the n minus 2 come from? Where do these things come from? Why does this work the way it works? Use the pictures that I've provided for you as support for your theory. You got 2 minutes as a team. I'll give you 3 minutes as a team. What is going on? And we'll come back together. Make sure you can articulate.
Okay, so like 180 and all shapes can make it to the side. And then the number of triangles no, the number of triangles
That would be. I think because any symbols have to have like such that are on the sides. Minus
because the triangle is the shape with the least amount of sides to make. Because if you get put 2 minus 2, then it would be 180 and just get out the line.
and then
No, because like the triangle is the shape with the smallest amount of sides. Yeah, if like if you put 2 for a head, you get 180, which is a straight line. But it's not a straight shape. So if you have 3 sides, you would subtract it to 180. And the total amount of triangle.
Oh yeah, we told us that. Yeah, I know. You told us that. Every time we do that, so 3 minus 2 is 1 times 48. That doesn't
Well,
equal 2.
because in the quadrilateral, you can make the diagonal.
And I do the quadrilateral. 4 minus 8 is 1.
And because the triangle has 180, is a total of 180 degrees, times 2. You multiply by 2.
That's 2
Find
triangles.
the total amount of interior. Huh? Tomorrow.
Or whenever your time is took me a mistake
All right, we're going to come back as a whole group. I apologize if I cut your conversation short. From what I could tell, most of you had pretty good, rich discussion. Let's see what you figured out. So, tell me what you figured out. Anything at all. We'll start with up here, and then we'll go there and there. So we'll start with Michaela, Alicia, then we'll go to Sebastian, and then we'll go to Anne. Go ahead.
Well, if you, the n, whatever, you know, the quadrilateral, if you, the sides, so there's 4 sides, if you subtract that by 2, the 2 is like how many triangles, like, it makes it how many triangles are actually inside.
Okay.
Diagonal, that's many.
Okay. Alicia, you were part of the same team. What do you say? Okay. Okay. Let's stick with that one for a moment. So she used the quadrilateral, and she said that if you take the 4 sides, subtract 2 from it, which is what this says to do, you end up with the number of triangles. Alicia, did that work for all of the pictures? It does. Okay. Good. Sebastian, your team, what did you guys come
I
up
don't
with?
know if it's the same thing they said, but the n minus 2 is whenever you draw all the possible diagonals inside in a shape, it's the total number of triangles that forms inside the shape. Because every triangle is 180 degrees, they go this one 180.
Okay. Okay, good. And your team, what did you guys come up with?
We came up with the same thing Kayla's team came up with, and I thought that the triangle was the only, not the only shape, but the only shape that would make sense to fit into every other polygon except for a triangle, because there's only diagonals in a triangle, and
Okay, good. So now Sebastian said something. He said if you draw all the diagonals, that's all the triangles. Anyone have any thoughts on that? Or thoughts on anything else? Chris, go ahead, on anything at all.
Well, first of all, I was going to say what we think
Go ahead.
kind of physically impossible for a polygon to have less than 3 sides because it only has 2 sides on the side it really flips off.
Very good.
And for pen drawing, I think there are 2 diagonals I can see right now where we actually that aren't shown.
Yeah. So we could draw a diagonal here. We can draw a diagonal here. And am I missing any?
Yes, one all the way at the bottom in the right corner, and one that's all the way at the
It's
Boy.
the
bottom.
opposite of that one that you just drew.
Yeah, right,
Oh.
you were just on it.
No,
No.
no, other
This-
vertex.
that-
Yeah,
Oh,
right there.
right
So
here,
it's that
to
one,
the-
yeah.
That's what I said.
It's just so.
Okay, so
Oh my god.
so we didn't draw all the diagonals. So what was done to get these pictures? Can someone articulate that? Catalina?
Well, no, not that. Can you put the lines on again?
Sure.
Because, like, I remember one time we were learning, I forgot what it was, but it was a lesson, and just look at the blue outlines in it. We did a problem like that, and we kind of, like, came up with the angles or something like that.
Okay.
Could that, like, support anything from a pentagon?
Not sure.
Because I see the same figure, and, like, that could be used to solve the pentagon.
Okay. You might be right. I'm just not sure. Okay. Jada, and then back to Michaela.
The amount of sides minus 2 might be connected to the amount of diagonals that you can make inside of a shape.
Okay. So it's connected to the number of diagonals that
But
you
it
draw.
just doesn't work for like the pentagon, like quadrilateral.
Okay.
It works more in a triangle.
Okay. Michaela?
Well, before you drew the lines, I was gonna add on to what Sebastian said, by 1 point. If you draw the diagonals from 1 point.
That's the key. So if you look, the diagonals are all being drawn from the same point. Even though this one's hard to see because only one was drawn, but if you draw the diagonals from 1 point, you end up with triangles. You would end up with other triangles as well, but there's no overlapping diagonals by doing it this way. And then I believe it was Sebastian's group that brought up, and I think others discovered this, that the sum of this will be 180, the sum of this triangle is 180, and the sum of this triangle is 180. This is a 5-sided shape. 5 minus 2 is 3. We have 3 triangles, multiply that by 180, and we'll get the sum of the angles in there. Okay? Any comments or questions? You guys have done a good job, so now we've done all the explorations, we've done all the investigations, so now we're going to do the application. So, pictures can be sketched. You don't need perfect pictures. So some of this is going to go quickly because the ideas are simple for you. But remember, we're trying to build a toolbox. At this point, our toolbox is incredibly extensive, and it's going to get more and more packed with tools. So the tool we're going to explore is using the polygon interior angles theorem. Find the sum of the measures. So it's an octagon. You see it in the picture. I also told you in the text. So we've got n minus 2 times 180 is going to tell us the sum. So if we just plug in the value, work it out, calculator or mental math. So 8 minus 2 is 6. 6 times 180. You could do 6 times 100 and then 6 times 80, and you could figure it out mentally. So what is the sum of the angles of an octagon? Sum of the angles. Jabari? Yeah, it's 1,080. 1,080 degrees. Anyone have any comments, questions?
Would there be a question that it would ask you to find the number of sides, and it tells you the sum of the measures of the interior angles?
Wait for it. Wait for it. Wait for it. All right. So the sum of the measures of the interior angles of a convex polygon is 900 degrees. Now tell me which polygon it is. You're saying you think this is a heptagon? It does? Okay, let's find out. So now we know that n minus 2 times 180, that tells us the sum of the interior angles. But this time we're told what the answer is. So we're being asked to go backwards. So what number minus 2 times 180 gives us 900? How many sides does it have, Alicia?
7.
So this has 7 sides. N is a 7-sided figure, and a 7-sided figure is called what, Alicia? And we were asked to classify the polygon by the number of sides, so this is a heptagon. Any questions about that? So we did a very basic use of the tool and a slightly more complex use of the tool. Any questions? Any observations or thoughts?
It's just a simple equation to solve.
It is. It does. At this point, right now, we're using it in a pretty simple way. Yep. All right. So now, go a little bit further. This is real. This is a real coin. It's a little bit hard to see because from you, and this goes back to what Anne said, if you looked at it quickly, you would think it was what? A circle, but it's actually not. So, you got, let's say, 2 minutes on the clock, and go. Make sure you read carefully. Read carefully, look carefully. 1 second, please.
Mr. Gallant, are we rounding? Like to the nearest tenth or just?
Whatever you got.
Yeah. Right, it's like and I patented. What? What? You need to get out. You need to get out.
One big point right now is
All right. Let's see how we did. We're back as a whole group, please. And part A only. Tell me what you got. I got student number 5, 18, and 12. Student number 5.
147.27.
Okay, student number 18.
I got approximately 147.27.
Okay, student number 12. Approximately 147.27. If you rounded to 0.3 or 147, as long as you said approximately, that's fine. What about part B? What is that called? I got student number 9, 14, and 6. Student number 9. Student number 14. Student number 6. It is called a decagon. Any concerns or questions? That's fine. Any other questions? So there was something extra that we hadn't done before in part A. What did you have to do in part A to answer the question? There's something extra, Jada. You said that so beautifully. Once you found the sum of the angles, you had to then divide by 11 to get the measure of 1. Because this is a regular. Only because it's regular, that means each one's exactly the same. You divide by 11 and you get the individual angle. Very important. You wouldn't be able to do it unless you had more information. Okay? Can't solve it, need more information, or something like that. Okay? Good. So let's take it to the next level by including some other tools. So again, I'm starting with some pretty basic stuff, and then we'll build on it. So what do we know already about this situation? What could you tell me right off the bat? Brandon? It's a trapezoid. What else, Alicia? It's a parallelogram. Are you sure? Okay, you retract your statement. Okay, what else do we know? Dalton? It does? How do you know? Okay, did it in your head? Or there's a corollary that says quadrilateral sum's going to be 360. So how could we find the missing angle? What can we do to find it? Marie?
Just add the ones that we had and subtract them by 360.
Add the ones we have, subtract it from 360. You guys are incredibly bright. You could use a calculator and just subtract, however you want. But basically, we've got x plus 108 plus 121 plus 59 equals 360. You can find the missing angle. Give me a thumbs up when you got it. Oh, everyone's got it already. What does it come out to? 72. Are you sure?
Yeah.
Because I don't want to write something down that's wrong. I was counting on you to tell me. 72 degrees? Good. Any questions about using what we know, using the theorems to find missing information? Any questions? So again, let's continue to build. So what do we know right off the bat, Michaela?
That angle T and S are the same
They are the same. How'd you know that?
because there's the arc one.
Beautifully said. Arc marks tell you they're equal. That's important. Okay? What else do we know? What else do we know just looking? Brian?
the sum of the interior angle will be 540 degrees.
540. How come?
Because when you're using the equation, you find n is 5 and so
Okay, so the sum's going to be 540, so we could write an equation that said equals 540, or you could just use some logic, mental math. It might help if you think about what Michaela said. If we called this x, then this would also be x because they're the same. So now we have a simple equation, 2x plus, and we got 93 plus 156 plus 85 is going to equal 540. Solve the simple equation, and you get the missing angles. So what does x come out to? What is x? Shelby? Can't hear you at all. Use the loud voice. 103? Okay, so 103, and so we're asked for the measure of angle S and the measure of angle T. They are both 103 degrees. Any questions on how we did that? Any concerns? So we basically used the same tool and used tools from the past to solve these questions. Any concerns? I accidentally wrote example 2. This is example 3. Apologize for that. So now we add in the last tool that you actually discovered last time we were together. The polygon exterior angles theorem. So in the previous 2 examples, and Dalton, I love how he said that he just did the expression mentally. So you had to figure out what the interior angle sum was going to be. But now we're talking about exterior angles. What's the sum going to be for the exterior angles? Back to Dalton. It's always going to be 360. So if you're dealing with exterior angles and you're asked to find a missing piece of information or what the sum will be, it's always going to be 360. And that you discovered during your exploration. So now we can write a simple equation. 2x plus 67 plus 89 must equal 360. Find x. 3x plus, 140, 156? Plus 156 equals 360. Find x. Give me a thumbs up when you got it. I'm so slow compared to you guys. Davis, what'd you get?
X equals 68 degrees.
Is that what you got, Alicia?
Yes.
X is 68. So we've got a 68 degree angle here, and then a 36 degree angle over there. Any questions about how we use the other tool? You already got it? Got some people who think they've got it already. Catalina, what do you think it is?
You know what? I'm not going to say how to do it myself, so you can call me Dalton.
Okay.
And then I'll tell you when
Okay.
or call me.
Okay. Dalton? 18. What do you think?
18 degrees.
You think it's? What did you think?
18.
Shelby? Okay. So yeah, it comes out to 18 degrees, but how? How did you do that, Catalina?
Okay, well, since it's a regular polygon, and since all the exterior angles are going to equal 360, I divided it by 20.
Yeah. So if it's regular, then all the exterior angles are going to be equal to each other. So if we take the 360 and divide by 20, you end up with 18 degrees for each exterior angle. Any questions about that, Chris? This has to be convex. In fact, all regular polygons are convex. Why don't you draw it out and you show me what you mean, okay? 'Cause I'm not sure if I'm following.
I have a question. Since that's 18 degrees, how far would you have to go, like for sidewise, to get an actual circle? Because that's very
It's, you would have to, it's not the same thing. A circle has no straight sides, so you can actually keep going forever and ever and ever. You could keep dividing by more and more and more,
1 degree.
and you get 1 degree, you'd get half a degree, you'd get 1/4 of a degree, you'd get smaller and smaller and smaller, and it would look more and more like a circle, but it would never be an actual circle. Okay? Good. So, checkpoint number 2. Got 2 questions. Now I'll put 2 minutes on the clock. All right. So let's see how we did. Part A, I've got students 2 and student 9. Student number 2, what'd you get?
For A, I got 30 degrees, and for
30, just A. And student number 9? So you two agree that it is 30 degrees. What about part B? I've got students 13 and student 20. Student number 13.
77 degrees.
Student number 20. You agree that it is 77 degrees. Anyone have any concerns? Okay. Team leaders, if you would hand the slip of paper to your teammates. Now, I apologize for not managing the time as well as possible. The discussions we had were valuable, so I didn't want to stop them. But I was very much looking forward to this activity, so I'd like to start it. And what I'll have to do is I'll cut it off, I'll cut it short, and it's not to mean that that it's not valuable, it just means that we're going to have to cut it and continue it. I'll have to find time later this week to continue the process, because 5 minutes is not enough time. But it is enough time to get started. So, here is the team challenge. You have a polygon. It's a regular pentagon. Suppose that we take BC and extend it further, and we take ED and extend it further until they intersect at a point. Write an expression for the exact area of CDZ. So, I'm going to put 5 minutes on the clock today we will get started, and then we will resume at a later time. You're going to need to discuss, you're going to need to draw. I intentionally gave you a slip of paper with lots of space to the side so that you could do the drawing. Okay?
You told us that when we extend the line, we're supposed to follow like that. Would that make sense? You told us that you extend like that.
Right, but that's not what we're doing. Now extend this.
Yeah.
Yeah.
It's like solving. It's like solving everything.
Okay, so as I indicated earlier, that is not the end. I'm actually not happy that I have to cut this off. I'm very proud of this group, and I was actually really looking forward to seeing the results. It feels like some people had some results already. Is there someone who wanted to share what their expression was to see if they got it already? Oh, go ahead.
How would you find one of the heights if like you already have a missing side and another missing side?
So now you have to think back to other tools that you've learned in the recent past. Because there's something going on. If you use the tools that you learned today and partner them with tools you learned in the past, then you will start to see the picture. Okay? I don't want to reveal too much. Brian?
I was gonna ask, can you add other stuff other than the 2 lines that...
Yes, absolutely. Can you draw in other lines? Absolutely. Okay? Dave?
When you get the segments CZ and DZ, they're equal to each other.
Can you prove that? Good. Good for you. You're on your way. Okay, so 1 second. I know there's other observations. So let me wrap up the lesson, and then we will revisit this. So your homework is on page 505. You're doing numbers 11 through 22. You're doing number 24, 25, and then 28 to 31. It's a total of 18 points. Please do the at-home tutor 8.2, and you will have a quiz on 8.1 to 8.3, but I'm not, it's going to end up being, let's see, we got 8.2 tomorrow. Yeah, it's going to end up being next week, but I'm not sure how the testing is going to, the writing test is going to impact that. So I'll have to find out, exactly what it will be.